All right, today we're going to finish up with right triangle trig functions and the fundamental trig identities. And so to do that, we're going to start by reviewing a little bit of what we talked about earlier in this unit, which was the sine, cosine, and tangent of a function. And so we talked about SOHCAHTOA, which was the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm going to write those here. That's opposite over hypotenuse, adjacent over hypotenuse, and the tangent is opposite over adjacent. Now, what does that mean? I'm going to draw a triangle here so we can talk about that, because that does depend on where the angle is. So if my angle is here, then the opposite would be this side. It is opposite to the angle. Adjacent would be here attached to the angle, and then hypotenuse would be this side across from the 90 degree. I'm going to go ahead and draw another triangle here. And if my angle is up here, then that means the opposite is on this side because it is opposite to that angle. Adjacent would be here, and hypotenuse again is the one across from the 90 degrees. So for right triangles, the sine of theta is opposite over hypotenuse. So we would come to this angle, whatever's here, divided by our hypotenuse. If it was this one, we would take whatever's here and divide it by the hypotenuse. Now, in the unit circle, remember the hypotenuse was 1, and so this was just the y value, the x value, and the y over x. So that's just a reminder from the unit circle. All right, when we're dealing with other triangles, so we talked about sine, cosine, and tangent. There are 3 other trig functions. They're called the reciprocal functions. And so from sine of theta, its reciprocal is called the cosecant, which is this one right here. So this is called cosecant. And it is the reciprocal. So it is the hypotenuse over the opposite side. So in this case, we would take whatever's here in the hypotenuse and we would put it over whatever's on this side. In some cases, you'll see that written as, or in the unit circle, that would be 1 over y, since the unit circle was y. So its reciprocal is 1 over y. So this one in the unit circle was x, and so its reciprocal would be 1 over, sorry, I wrote y, that should be an x there. X. So our secant then is the hypotenuse over the adjacent. And then our cotangent would be the adjacent over the opposite. So these are reciprocal functions. You're going to flip them. Now, the most common mistake I see with students is that they want to match the sine with the secant for some reason, because it's got the 2 S's, I guess, and cosine and cosecant, they want to match the 2 C's. That is not the case. The cosecant is the reciprocal of the sine, and the secant is the reciprocal of the cosine. So make sure that you understand that. This is the one nobody messes up. Cotangent's the reciprocal of the tangent. All right. Let's look at some fundamental identities. We're going to use these more later, but since we talked about cosecant being the reciprocal of sine, secant being the reciprocal of cosine, and cotangent being the reciprocal of tangent, we figured we'd show you these identities now. So sine of theta is 1 over the cosecant, since those are reciprocal. And so you could also say that the cosecant of theta would be 1 over the sine of theta. For the cosine, that's the same thing as 1 over the secant of theta. And again, you could say the secant of theta is 1 over the cosine of theta. And then the tangent is 1 over cotangent of theta. And you can say cotangent of theta is 1 over the tangent of theta. We'll use those more once we get to verifying, but we wanted to make sure we showed it to you here since we're talking about those reciprocal identities. The quotient identities, and we talked a little bit about this when we did the unit circle. We said that tangent was y over x, which means that it was the sine of theta over cosine of theta. So you should recognize that the tangent of theta is the same thing as the sine of theta over the cosine of theta. which means that the cotangent would be the cosine of theta over the sine of theta. So those are some things just to get started getting used to those before we get to the verifyings. Now, we're going to look at an example where we have to find all 6 trigonometric functions of theta. On the test and on the unit circle portion and the other portion, you will have to find all 6 of the trigonometric functions of an angle in a couple different ways. So we're going to start with this one here. They gave us a right triangle and they told us that this side is 2 and this side is 4, and my angle is in this bottom left-hand corner. We're going to be putting a lot of stuff together that we know. So back in middle school, you learned the Pythagorean theorem. That's what you should be using here to find the other side. And so my a squared plus my b squared, which is 2, is equal to my c squared, which is 4 squared. The hypotenuse is always the c squared. And so we get a squared plus 4 is equal to 16. I subtract the 4, and then we take the square root. Now that's a radical that can be simplified. The biggest perfect square that goes into 12 is 4. And so the square root of 4 is 2, and what we're left with is 3. So this side right here is going to be 2 root 3. That's the first step you should take, is to make sure that you have all the sides so that you can set up the ratios. And so now we can start setting up all of our ratios. So cosine of theta, we said, is adjacent over hypotenuse. So this is my adjacent, 2 root 3, and my hypotenuse is 4. You wouldn't want to leave that like that. You can reduce this. 2 goes into both of those. And so 2 goes into 2 one time, so we're left with just the square root of 3 on top. And 2 goes into 4 twice, so that's a 2 there. We're just reducing that fraction. The next one, our sine of theta, is the opposite over the hypotenuse. So my opposite from theta is 2. Over the hypotenuse is 4. And that reduces to 1/2. Now we've got our tangent of theta. That is the opposite over the adjacent. So 2 over 2 root 3. I can reduce that. These 2's cancel out, so I'm left with 1 over root 3. Now, we do not leave a square root in the denominator. Remember that, so we want to rationalize. When you rationalize, you multiply times root 3 over root 3, because this is the same thing as 1, so I'm not changing the value. But when I multiply across now, I'm going to get the square root of 3 on top. And on the bottom, the square root of 3 times the square root of 3 gives us the square root of 9, which is just 3. All right, now our other 3, which are the reciprocal ones. So the reciprocal of cosine is secant. So that's the one I'm going to do next. And it is flipping this right here. And I can take this one that's already simplified. So I flip that and I get 2 over root 3. Again, we have to rationalize because we do not want to leave a root in the denominator. So I multiply times root 3 over root 3. I multiply straight across and I get 2 root 3 over 3. Our next one, the reciprocal of sine is cosecant. And so I'm going to take this and I'm going to flip it. And when I flip this, I get 2 over 1, which is just 2. And then our last one, the cotangent of theta, I'm going to flip this one. Now I'm going to go ahead and flip here before we rationalized. That way I don't have to rationalize again. The square root of 3 would go to the top, the 1 would go on the bottom, and so this just leaves me with root 3. So there is all 6 of the trig ratios for my triangle here. Again, on the test, you're going to see this a couple of times. You've got to be able to find all 6 of the trig ratios for it. So let's try a couple different ways that you're going to see this. We'll come back to that part with the calculator. So here it says, let theta be an acute angle such that sine of theta is equal to 0.6. Find the values of the other 5 trig functions. So this is one way that you would see this question. And before we get started, there's a couple things we're going to want to do. And we always want to draw the triangle. That's one of the things we're going to want to do before we get started. But even before I do that, let's define a couple things. Acute, remember, that is less than 90. That is an angle that is less than 90 degrees. That's going to put me in the first quadrant. So when I draw my triangle, I'm going to want to be in the first quadrant because it says acute, so I know it's less than 90, so it's got to happen in that first quadrant. You got to think through those things as you're drawing your picture here. The next thing I'm going to want to do is change this to a fraction. And so 0.6 is the same thing as 6 over 10. And then we can reduce that to 3 over 5 because that fraction reduces. If you forget how to change that to a fraction and it's on the calculator portion, remember you can push 0.6 and then hit math, enter, enter, and that will get you the fraction form. But you do have to get it in fraction because remember sine is opposite over hypotenuse. So I'm going to put 3 as the opposite and 5 as the hypotenuse. And at this point, you should recognize this as one of the Pythagorean triples. That's back from geometry. You could still do this with the Pythagorean theorem if you forget that, but you're a whole lot faster if you remember those triples. So this would be a 3, 4, 5 triangle. So I label my triangle, and now I'm ready to get started on those trig ratios. So my first one, which would be cosine of theta, it doesn't really matter which order you put it in, but cosine of theta is the one I'm going to start with. So we're doing this cosine, and it is the adjacent over the hypotenuse. So my adjacent here is 4, and my hypotenuse is 5. So that would be our ratio. The sine of theta, I'm going to go ahead and write it here. It was already given to me. It was the 3 over 5, but I'll go ahead and write that out so that we have them all. And then our tangent of theta was the last one that we're going to do. And so that's opposite over adjacent, and so that is 3 over 4. Now, in this case, our reciprocal ones are going to be really easy since these were all very basic fractions. Cosine is going to be, the reciprocal is secant of theta, and so that's going to be 5 over 4. The sine, its reciprocal is the cosecant of theta, and that is going to be 5 over 3. And then the reciprocal of tangent is going to be the cotangent of theta, and that will be 4 over 3. They are reciprocals, so they are flipping. And so that would be all of our other 5 trig functions that they didn't give us. All right, for example 4, here we're getting a little bit harder with it. It says if tangent of beta is equal to 4 and the sine of beta is less than 0, find the values of the other 5 trig functions. So before we get started, again, we want to draw our triangle, but to do that, we're really going to have to think through the situation. We know that whole numbers are over 1. So that is our values there, and tangent is opposite over adjacent. So we know that we've got the opposite and the adjacent there. Now, it's told us that sine of beta is less than 0. So it's telling me that the sine is negative. And so we did talk about this earlier, but let's sketch a picture here. When we were talking about our unit circle, we said that we can figure out where the different trig functions are positive. And we said all of them are positive in the first quadrant. The sine is positive in the second quadrant. The tangent is positive in the third, and the cosine is positive in the fourth. That does go for its reciprocals as well. So the cosecant would be with the sine there, and the secant would be with the cosine, and the cotangent would be with the tangent. So this is where they're positive. So we can use this to figure out which quadrant this is in. I'm going to show you another diagram here just to think about these triangles. So we've got 4 options here for triangles in each one of the different quadrants. Now we know that this part here is always going to be positive. The hypotenuse is always positive. For our x's here, since 0, 0 is right here, all of these x values are going to be negative. So this middle part's going to be negative, and the x values are positive on the right-hand side. For our y values, they are positive when you go up and negative when you go down. So this would be positive, this would be negative. So there's just a little diagram on showing you what the signs are for each one of those points that are there. So let's go back to this one. It says the sign is negative. So that's going to take out both of these because that's where sign is positive and that's where they're all positive. It has to be one of these two. Now, the tangent value that they gave us is positive. That means that this is the correct quadrant right here, quadrant 3. So we're going to have that triangle drawn. Here's my angle. So you're really going to have to think through that to see where the correct values are, because now we know this tangent is positive, but this and this are both negative. We've got negative and a negative right there. So I know both of those values are going to be negative. So my opposite is going to be -4, and my adjacent is going to be -1. Now I can do the Pythagorean theorem now so that we can find this hypotenuse. And so we get -1 squared plus -4 squared is going to be equal to that c squared. And so that's going to be 1 plus 16, which is 17. We take the square root, and that can't be simplified, so that's going to be my hypotenuse right there, square root of 17. Now we're ready to set up our trig functions. Don't try and skip just to the trig functions because that usually causes errors. So we'll start with our, I like starting with the cosine. So we'll start with our cosine. And that is adjacent over hypotenuse. I cannot leave it like this because we do not want a radical in the denominator. So I'm going to multiply times the square root of 17 over the square root of 17. That's the same thing as 1. And so we get -√17 over 17. Then we go with our sign. That is opposite. And so that's -4 over hypotenuse, which is the square root of 17. Again, I need to rationalize this. And so I'm going to end up with -4 root 17 over 17. Then we go to the tangent. And so that is opposite over adjacent. They already gave us that one, which was 4. I'm going to run out of space here, but we'll try. So secant of theta, that's going to be my reciprocal for this cosine. I'm going to go ahead and flip this first one. That way I don't have to rationalize again. So square root of 17 is going to go up and -1 is going to go down. So that is the negative square root of 17. My next one is going to be the cosecant of theta. That's the reciprocal of this one. So I'm going to flip it. And so I get root 17 over -4. And then my last one is the cotangent of theta. And so that was 4, and whole numbers are over 1, so this would be 1/4. I think this is a good place for you to pause and try it yourself. Go ahead and try that example 5. I will go ahead and do it as well, but if you pause it and check your work, that's probably going to be the best. All right, so I'm going to start by changing this to a fraction, so I get -24 over 25. My sine of theta is positive, and so I need to think about what quadrant that goes in. The cosine is negative, and the sine is positive. So I need cosine negative and sine positive. They're all positive right here. So both of these are going to have to go. I'm sorry, they're all positive right here, and cosine is positive right here. So these two go away. So I'm looking between these two right here. I need my sine to be positive, so I'm going to need it in this quadrant right here. So we've got our triangle in quadrant 2. There's my adjacent and my hypotenuse. Again, I should recognize that as one of the triples, so I get 7 right here. And so now I'm ready to set this up. I'm going to start with my cosine, which they gave us. Then my sine of theta is next. That is opposite over hypotenuse, so I get 7 over 25. Then my tangent, I get 7 over -24. That's opposite over adjacent. Now my reciprocal. So secant is the reciprocal of cosine. So I'm going to flip this one, and I get -25 over 24. Cosecant is the reciprocal of my sine one, so I get 25 over 7. And then cotangent of theta is the reciprocal of this one, so I get -24 over 7. So there's my 6 trig functions. All right, the last thing I'm going to do with you guys is do the calculator for these reciprocal functions, just to make sure you know how to put those in there. The first thing you want to do when you're doing the trig functions in your calculator is always to check the mode. So in this one right here, I would want to be in radian mode. This as well is in radian. And this one is in degree. And so that does matter. You have to have it in the correct mode when you do your calculator. So make sure that you're checking that first. I knew this was degree because there's a degree symbol. These do not have degree symbols, so I know that they're not degree. All right, so here we go. First thing I do, mode, and put it in radian mode. And then to put in the cosecant, that is the reciprocal of that sign. So there's where we were talking about earlier. You want to recognize that. So this would be 1 over sine of 1.3. And that's the way you're going to have to put it in the calculator, because the calculator only has the sine, cosine, and tangent. Now, you see the inverse ones in there. That is not the same thing. Remember, this inverse is when we're looking for an angle. So you do not want to use the inverse ones. It is the reciprocal. You are flipping it. So you would put 1 divided by the sine of 1.3 and hit enter. And so there is our value. We do leave 3 decimals. 1.038 would be our first one. For the second one, we're still in radian, so I don't have to change the mode. But this is the reciprocal of cosine, so I would want to put this in as 1 over the cosine of 7 pi over 8. And you do want to use the pi symbol, not the 3.14. So we hit 1 divided by the cosine, and I'm going to go ahead and put the fraction bar there just to make it look exactly the way it does on my paper. 7 pi over 8. For this last one, I do need to change the calculator mode to degree. And so now I'm ready to put this one in. Cotangent is the reciprocal of tangent, so I'm going to put 1 over tangent of negative 320 degrees. So 1 divided by tangent of negative 320, and we get 1.192. So that's putting it in the calculator for those reciprocal functions, trig functions. Make sure that you're able to draw the triangles, get all 6 of the different trig functions. Thanks.